So we've talked about reflection and light waves bouncing off of a surface, and now we're going to talk about transmission and refraction. So transmission is when light passes through or enters into a new medium. And when this happens, something called refraction occurs. So essentially, we said that the speed of light in air and in a vacuum is 3 times 10 to the 8th meters per second. However, as light enters into a medium that has a higher density or is a different substance, it's going to start to go a different velocity. It's going to actually slow down. And as a result, it's going to bend when it enters that medium. So if we look here and light enters through glass or into glass, it's actually going to slow down, and you can see that the light bends towards what is the normal line. Okay, so that's the same normal line as we saw where the light struck a reflecting mirror. And so it slows down and it bends towards it. Okay, now the ratio of the speed of light in a vacuum to the velocity of the speed of light in a new medium is called the index of refraction, and it's written with the letter N. So you see here C over V is equal to N, or the index of refraction. And it's sort of a known value for different types of transmitting or light transmitting materials, and it's a property of that material. We can actually determine what kind of glass we have or what kind of substance we have based on the index of refraction. Okay, so it would be C, the speed of light, over V, the velocity in that medium. Let's go ahead and just take a look quickly at a simulation. You're actually going to use this in one of your labs. Okay, so you can see I turn the light on and I strike the surface, and here I've got a transmitting surface and it's water. Okay, and as it strikes the surface, some of the light is reflected and some is transmitted. But you can see that the light bends towards the new medium, and it's actually slowing down in that medium. And here we have the index of refraction for water being 1.33. So if we look at the Elmo, let's just kind of show where that comes from. So I have an index of refraction, and I know that that is C over V. And I just said the index of refraction for water is equal to 1.33. And that's just pure like tap water. It depends on the type of water. It can be a little bit different for salt water. All right, so let's figure out how fast that light is traveling in the water. Okay, so I say 1.33 is equal to 3 times 10 to the 8th meters per second over V, and I'm going to solve for V. Okay, notice that the index of refraction is greater than 1. That's because the bottom of the fraction can never be faster than the speed of light. The speed of light is the fastest anything can travel, and we've never been able to exceed the speed of light. So the V is always going to be smaller than the C on top. So your index of refraction is always going to be greater than 1. But in order to solve this, I'm just going to multiply by V on both sides and then divide by 1.33. And so I'll take 3 times 10 to the 8th and divide that by 1.33. So 3 e to the 8th. And I get that, oh Lord, it's times 10 to the 8th. Okay, so it's 2.26 times 10 to the 8th meters per second. And so this would be the velocity of light in water. Okay. Now, if we go back and we look at the simulation quickly, let's look at the angle that these things travel, right? So we are going fast, and then we slow down a little bit, and notice that it bends towards the normal because it's slowing down. Okay. Let's change the mediums. Let's start in water. Okay, you can see as it transmits from water to water, we're not going to have an angle. But let's say that goes from water to air and see what happens. All right, so I put it in air, and you can see now the light actually bends away from the normal. So it's going slow, and then it's going a little bit faster. So something about that light bending is going to help us to determine what these materials are and whether or not their relative index of refraction. So if we go back to water, and then we go to air, you see it bends away from the normal line. So in the next video, we'll figure out how to relate the index of refraction of one medium to the other as they pass through an interface.